All right. Good afternoon, everybody. My name is Jean Larrieux, and I'm gonna do the Super Bowl bat. Basically, the idea behind my concept for this final project is that we had a first project, the bowl bat, that you can see in the previous, but there was a lot of limitation with it. The breadboard that they offered was very, very, very small, so you couldn't fit a lot of things in there. And there was a lot of complication with the programming. So I decided to modify it and to make the best out of it. All right, what I'm going to use as components, you guys are familiar with the Board of Education, BS2 stamp. But what I added, I actually purchased 2 extra breadboard. I also added another chassis and linked them together, 2 ultrasonic sensor, 2 LEDs, and 3 QTI infrared sensors. The good thing about those sensors is that they send the pulse and they record everything also at the same time. So it's an infrared sensor all in one. All right, this is what it looks like after all the mounting. I actually decided to go with bigger wheels on the back. The main reason is that if you have same size wheels, because of the length of the robot, turning is very difficult. If we had the same size wheels and we sent the turning signal, it would take a while. It would actually take a big space to turn. But with bigger wheels, it just pivots on the big wheels. So that was one of the problems that we encountered. We encountered a lot of other challenges too. Having 2 chassis. Having 2 chassis is a problem because they were not really designed to be linked together. So we had to figure out a way to link them. Also, working with the LEDs, we also encounter some problems. Also, having like 3 breadboards in general, linking them and doing the circuit right, because we're mechanical engineers, you know, we're not electrical. Having 4 wheels also, because that's another extra constraint, because working with the previous Bobot, we only had 2 wheels, so we had to heavily modify everything. And, you know, the cost of the extra component. And also, a big problem we ran into, since we have so much equipment on there, the small battery pack that comes with the Bobot doesn't last very long because all those components are drawing power. So if I was to do this again, I would definitely try to add a better power plant. And electrical power also it's a little complicated as far as how to wire everything. All right. Basically, the modified robot is just an obstacle avoidance robot, but it's an intelligent obstacle avoidance because inside of the obstacle avoidance, we decided to put a lot of extra things in there. One of the many problems that was with the previous Bobot is that when you're doing obstacle avoidance, you would come to an obstacle and try to avoid it. But when it's doing the avoidance, if it comes to a next obstacle while doing it, there's nothing in there to prevent it from hitting that second obstacle. So I wanted to put something in there that would constantly check, even when it's avoiding things, that would constantly check if there's other things around. That's one thing. Another thing I wanted to also address was backing up. A lot of time when you're backing up, there was no sensor in the back to detect anything. So the original Bobot would just back up and hit anything. So I also added another sensor in the back. And on third things I wanted to also address is that a lot of time when you're dealing with the previous Bobot, you didn't really know what was going on if you didn't have it linked to a computer. So I wanted to add some LEDs, and those would be somewhat like pointers telling me what the Bobot is doing at the time. I don't know if there's any questions. Anything. What?
Your other member.
Me, myself, and I. All right, the video demonstration.